later. Okay, 3. Oh, this looks like the last one. Piece of cake. 3. 6, 2. That would be 3. How many oxygens do we have? How many? 9 oxygens. Okay, we're cooking with gas, as they say. Okay, so we got 2. 2 times what equals 9? 4.5. Did you see how fast he came up with that 4.5? Good man. Good man.
How'd you get 9 again? So,
2 times 3 is 6, plus 3 is 9. Okay, we can't have 4.5 and leave it that way. What do we have to do? Yeah. Times 2. So that makes this 2C3H6 plus 9 O2s, 6 CO2s plus 6 H2Os. There we go. Bless you. There we go. And that's how you do it.
Do you always resort to 2? Or
Do we always do what?
oh, never mind.
Okay. I thought you would think about it first. Okay. All right. Now, there, on the back of this, bless you again, deja vu. On the back of this, there's balancing chemical equations. So, this balancing chemical equation thing, I borrowed. This is Dr. Munsey's, okay? So, I do not have the actual Word document. All I got, this is a scanned in thing here. There are mistakes, a few. Like what? Well, a few. Well, like what? Like right here, that Li is Li3. It's Li3PO4. So change that. Yeah. Well, that's what it is. Why is it that? Well, I'll show you why it's that. You would know that if you had... Li is Li plus, PO4 is phosphate, and everybody knows it's 3 minus. So if I'm going to make a salt out of this, what's the salt going to be? If I'm going to add these together to make a salt, I've got to put 3 of these to 1 of these, and so it will be Li3PO4, and that's what goes there. Capiche? Okay, good. Okay. So here we go. Let's try some of these. Some of them are not bad. Some of them are easy. And a couple of them are, what's the opposite of easy? Hellish. Right, okay. So let's look. Now, I will say this, there are 15. Do you observe there are 15? So I've got 2 daughters, both of whom had high school chemistry. And one of them had a teacher who thought, well, if 10 are good, then 50 is much better. And so they went over this. She came home, 50 of these to do. She did all but 3, and then saved those because Daddy would be home after a while. I was teaching the lab. Got out of lab 9:30, went home. Last thing I want to do is look at chemistry. So she shows me this piece of cake. Not a problem. This is what I do. I looked at it and was like, holy crap. I worked on those things, finally got them. It was like a multi-step reaction, seemed like. Anyway, 2-3 hours later, got something, went to bed. It was real late. Next day, turns out it was typos. It was typos. Can you believe that shit? Typos. So anyhow. Yeah. Well, it's because it's hard for me to believe that other people are fallible. I think everybody's perfect. So anyway. Okay. Let's look at this. Fe2O3, which, by the way, that's iron. Fe2O3. By the way, what would you name that? Fe2O3. Iron 3 oxide. You got that, man. Iron 3. You know how he did that? Well, other than being super clever. That charge is 3, that charge is 2. Yeah, there you go. One of them's plus, one of them's minus. The plus is in the first one, okay, because the cation is first. Okay, let's do the first one because this one is probably super easy, right? Okay, here we go. We've got 2 irons here and we've got 1 iron here. So what do we need to do? Okay, I'm about done now. Okay, we've got 3 oxygens and 1. What's 3 plus 1? 4. And then we've got how many here? Piece of cake, right? Put a 2 there, right? Wait a minute. If we put a 2 there, what happens over here? And we put a 2.
Carbon.
Yeah, we have to, but what happens? Then we get 5 oxygens and 4 oxygens. That's not going to work. What do we do? The 2 didn't work. What do we try? 25? No way. Well, let's try 3. If we put 3 here, we have to put 3 here. So 3 here means we got 3, and 3 is 6. 2 times 3 is 6. So that works. So now, is there a super easy, clever way to do this?
What about in front of iron?
Right here?
Yeah, just
Nothing, honey. You don't have to put anything. Okay? It's assumed it's 1. Okay. There should be a super easy way to do this, a quick and clever way. And I knew it one time, but I forgot. How could you forget? Because you don't do this that much. You do it when you're in freshman chemistry. Okay, so here we go. I've got P2O5, and I've got H2O, and then H3PO4. So I want to balance this. What do you want to balance first? Which element? Phosphorus. So I got P2. What do I have to do over here? 2. Okay, that was easy. Now, what do you want to balance next? Not the oxygen, because see, it's in 2 places. So what do you want to balance? Hydrogen. So how many hydrogens here?
6.
What do I do?
3.
Okay, now let's look at the oxygen. I got 5 plus 3 is 8. I've got 2 times 4 is 8. Everybody's balanced. Everybody's happy. Yeah, see, this is a good story. Good story. Okay. Barium oxide and barium oxide. This is barium oxide. I don't know what the hell this is. What is this? BaO2. I mean, barium oxide. Barium has a 2 plus charge. Oxygen has an O minus. This is barium oxide. Yeah, kind of interesting. I'm not sure where this came from, but here we go. We got 1 barium. We got 1 barium. The berries are happy. Let's look over here. We've got 1 oxygen and 2 oxygens. That's 3. There's a problem there. What's the problem? Oh, it went out. Okay. This is embarrassing. I can tell you a joke while we wait for the lights to come on. I don't want it to be a waste of your time. So I'll tell you one that you'll learn from, okay? So this guy passed away, and he was not a particularly nice person, and he went to the bad place. And so he gets there, and they tell him that he gets to pick where he's going to spend his eternal damnation, his punishment. So they take him in room after room after room, each one worse than the other, and he's getting kind of depressed. Finally take him to this one room, everyone's standing around, waist deep, here we go, waist deep in manure, smoking a cigarette and drinking a cup of coffee. Okay. He goes, oh man, this is pretty gross, but all those other rooms, this is a lot better. He said, I'll pick this one, and then poof, he's out there, cigarette, and a cup of coffee, waist deep in manure. He's standing out there, he's going, well, it could be a lot worse. Then he hears this booming voice. Coffee breaks over on your heads for 1,000 years. So anyway, why did I bring that up? Anytime we're to get back to work, I say, back on your heads. Okay, and you know, back on your heads for 1,000 years. So here we are, back on our heads. Even number, odd number. How do you change an odd number to an even number? Multiply by 2. So I'm going to multiply it by 2. What does that give you? 2 oxygens and 2 oxygens are 4. 2 times 2 is 4. That works out. We're in good shape. Let's do the next one. Shall we? Oh, let's. Now, I don't want to shortcut, but I'm going to shortcut this for you. How so? Do you notice that PO4 is PO4 here and PO4 there? Did you notice that? Okay. It stays together. It doesn't break up. We don't have like a P over there and a... It's all together. So what we're going to say is the PO4 stays together. Okay? So we've got SrCl2 and we've got PO4 here, and we have 2 PO4s over there. So, you know what I'm going to do? I'm going to look at the PO4 as a whole thing, and I'm going to say 2 PO4s here. I'm going to say 3 SrCl2s because I've got SR3 here. I'm going to put a 3 there. Let's see what we have to do over here to make things work out. So we've got 2 times 3, that's 6 lithiums. We've got 3 times 2, that's 6 chlorines. So we put a 6 there, and it all balances out. Okay, what do you guys need to do between now and next time with this? I would say try to work these as best you can. Some are going to be easy and some are going to be a little harder. Okay? And in the chapter, Writing and Balancing Chemical Equations, they have some for you to try. Please try these, because the more you work, the easier they get. And I'm not giving you 50. You're not getting 50. You're getting 15, and then 1, 2. Yeah. That would be what? 17. Okay. So try those.
The S and the how it said solid and gas.
What's that?
You know how on the right balance equation says solid and gas? Do you pay attention to those?
It's not up on here. It is in the book. It's going to make a lot of difference once we get past chapter 3. When we get into chapter 4 and onward, it makes a difference. Okay? Chapter 6, absolutely. Because they have different values when we look it up in tables. Things. Okay, so now, here's what we're going to do, the last part. What is the last part? Organic compounds. Are you ready? This is the push, the final push. You know what comes after this? Dinner. Okay. And I'm going to give you your book back. Thank you so much. You're a scholar and a gentleman. Okay, organic chemistry is a whole different branch of chemistry. Everything that you learned about naming stuff up to now is kind of out the window with organic chemistry. They got all their own stuff, and I'm going to explain it. To do this justice, it'll take like 2-3 weeks or 4 weeks. But I'm going to do it all in 12, 14 minutes. Okay? All right, so we'll see what we can do. At first, chemists thought there were 2 distinct classes of compounds, organic ones which were produced by living things, and inorganic ones were like rocks and minerals. Okay? They believed you couldn't synthesize organic compounds starting with inorganic compounds because there was a vital force that was necessary. Okay, so there was some Yoda stuff going on. There really wasn't. By the way, it was called vital force or vitalism. It was disproved in the early 1800s by Friedrich Wöhler, who made urea from a reaction of inorganic salts. So he showed that that was not a real thing. Okay, Kekulé came up with the modern definition of organic chemistry, okay, which is the chemistry of carbon. Biochemistry is the chemistry of life. Kekulé also came up with the structure of benzene. He fell asleep next to his fire in his easy chair, and he was smoking his pipe, fell asleep, had a vision of what the benzene molecule looked like, which is really kind of a bizarre thing, what it looks like. So I'm not saying what he was smoking in his pipe, but it was really kind of interesting. Okay. There are about 1 million inorganic compounds. There are more than 12 million organic compounds, and the number is climbing because carbon can do all kinds of things that the other elements can't. Carbon forms 4 bonds. That's important. Carbon forms stable bonds with other carbon atoms to make long and short chains. Carbon forms strong, stable bonds with hydrogen, oxygen, nitrogen, sulfur, and all the halogens. There are 2 ways of obtaining organic compounds: isolation from nature and synthesis. Isolation from nature would be this. Salicylic acid is what you use to make aspirin, and is found in the salix tree, willow tree. And so people used to chew on willow tree bark if they had a fever, and it would make the fever go down. Okay, how come? Because it wasn't exactly aspirin, but it was the ingredient in aspirin that made the fever go down, is what salicylic acid is. If you take bark and you boil it, and then you gather the crystals, and you guys know how to do stuff like that, you are isolating it from nature. If you get some bottles off the shelf and you start from scratch to make something like that, you're doing synthesis. So that's what the difference in those things are. Okay? All right. Hydrocarbons have, are you ready for this? Just carbon and hydrogen. Hence the name hydrocarbon. They are the simplest organic compounds. And there are 4 families. Alkanes, which have only single bonds. Alkenes have double bonds. Alkynes have triple bonds. Yeah, carbon can do triple bonds. And aromatics have alternating double and single bonds. They are like benzene, okay? They are like benzene. So, what we want to do, ever so briefly, because we don't have a lot of time, we just do not have a lot of time to do this, is to name these things, okay? And I'm going to turn this over. In order to name organic compounds, you need to know these. These are the prefixes: meth, eth, pro, bute, pent, hex, hept, oct, non, and dec. Okay. How does it work? Well, I'm going to start with the simplest organic molecule. Are you ready? Is it on the paper? Okay, there we go. It is 1 carbon, so it's meth. And it's an alkane, because they're all single bonds, so it's methane. So that's how you name it. Okay, how many carbons? 2. So what would it be? And it's an alkane, so it's ethane. Ethane. Okay, what would this be? 3 carbons. Say it right. Propane. Okay, there we got propane. Now, notice you're drawing a buttload of hydrogens there. It can get pretty complicated doing it like this. So there's another way to write this, and it's this way. CH3, CH2, CH3. And it's the same thing as propane. This is called the condensed chemical formula. Condensed formula. It's easier to write it that way. Okay, so now, here we go. Let's do this. You guys are learning some stuff here. Okay, how many carbons? 2, so it's F. And look, that is a double bond. So what is this called? Ethene. And it can also be written like this. So far, so good. Yes, sir.
For the propane, why isn't the other one wrote as HC instead of the CH? Look at it.
I felt like just know that in this, the carbons are connected, okay? Here, I've got the double bond between the carbons. I want to show that, so that's why I do that. Okay, what would this be? Yep. Ethine, which is also, it's got a common name. It's acetylene.
Sorry, 450.
10-4. Okay. All right, now there's also now I'm not going to show you an aromatic because those names are different. Okay. What I'm going to show you now is functional groups. Bless you. I'm just going to show you one. Alcohol. Okay. Alcohols have an OH group. That's what makes them an alcohol. So here we go. I've got COH. And it can also be written like this. Or it can be written CH3OH. Either way. And what you do is you take the alkane name and you replace the E with OL. So this becomes methanol. It becomes methanol. You got that? Methanol. I will do one more. Okay, here we go. What is this one? There are 2 carbons, so what will it be? And it doesn't get any harder than that. I mean, I don't see what the whole thing, I mean, it's not too bad. Do you want to do any more, or you had enough? What?
I didn't say anything.
I heard had enough from the back. What we'll do, there's just a couple more. We'll do those on Thursday. Tomorrow, please wear shoes. Wear shoes. If you don't wear shoes, I got to make you leave. I don't want to make you leave. Wear shoes tomorrow. No sandals in lab. Wear shoes. Did I mention shoes? Yeah. Wear them. Everything else is, whatever, but wear shoes. Got to have shoes. We've got aprons for, But be modest, for goodness sake. Okay, somebody turn that off. Anybody turn it off?
How you doing?